Hi, it's Mr. Sarisa, and I'm going to help you with this purple sheet that you had. But I am only going to do the ones to do by hand, not through the calculator. So let's start with the first one. The parabola's y-intercept. If it's in standard form, you just use c. And so the y-intercept is going to be at 0, -2. For B, calculate the coordinates of the vertex. And then C says the axis of symmetry. So really you would do the axis of symmetry first, x equals -b/2a. And seeing that b is 5 and a is -1/2, I would say -5 over 2 times -1/2. So the negatives would cancel, the 2's would cancel, and I'm just left with 5. And then to find the rest of the vertex, I would plug it back in and find the f of 5. So -1/2 times 5 squared plus 5 times 5, and then -2. And so I'm running out of room here, but that would be -25 halves, and then 5 times 5 is 25, so that's 50 halves. And then subtract the 2, which is 4 halves, and that comes out to 21 halves. And so our vertex is going to be 5, 21 halves. All right, so let me actually get that. That's the answer to B. This is the answer to A. And x equals 5 is the answer to C. All right, and then D is the domain and range. So the domain is going to be all reals because it always is for quadratics. And the range will be y, all y's, such that y is less than or equal to, because the a is negative, and then 21 halves, which comes from the vertex. From here, put it in here. And then finally write the equation in vertex form. I am going to put that over here. And so start with -1/2, x squared plus 5x minus 2 is the original equation. I factor out the 1/2, so x squared, and it's minus 10x because 5 divided by -1/2 equals -10. Okay, and then we need to complete the square, and then -2, and then we're going to have to add back whatever we put in that square times the a. So -1/2, that will become x minus 5 squared, because when I cut -10 in half and square it, that becomes 25. And that will simplify down to -1/2 times x minus 5. And if I add that 1/2, I have to add back -1/2 times 25, so -25 halves. And then add it to the 2, or -2. Sorry, I have to add that because that was a -25 halves because of the -1/2, and then I'm doing the opposite. And that 2 becomes 4 halves, and so that becomes a positive 21 halves. And there we go. That's in vertex form, so you can see the vertex is still 5/21/2, either way that we do it. All right, let's look. I can look at that a little longer. All right, and then we'll look at this one. Give the vertex and axis of symmetry of the parabola. So this one's a little bit easier because you just look at the h and the k. So it's x minus h plus k, right? And the a is in front of it. So the hk is the vertex. So the vertex here is going to be -5, -16. And the axis of symmetry is where the axis of symmetry goes through the vertex. And so since the vertex is -5, -16, axis of symmetry has to be x equals -5. All right, what's the y-intercept? The y-intercept is when x equals 0. So I'll have to find out what y is when x is 0. And so I just worked that out. 0 plus 5 is 5, so 5 squared is 25. So 4 times 25 minus 16 equals 84, 100 minus 16. So that's your y-intercept at 0, 84. All right, so let me start boxing my answers. That was C. This is, wait, just kidding, that's B. And this is A. And then axis, or domain, as always, is all real numbers. The range is going to be opening up, so it's going to be all y's such that y is greater than or equal to, and then the vertex is at -16, so -16. And then write it in standard form. I am going to have to slide over for that. So that one is y equals, that was 4, oops, 4 times x plus 5 squared minus 6, no, yeah, minus 16. All right, and so I square the stuff on the inside. Order of operations says I need to square that stuff first. So square the first, square the last, and double the product. So that would be 10x. And then I did the exponents, now I do the multiplication. So 4x squared plus 40x plus 100 minus 16. And simplify. Do the adding and subtracting. And there we go. That was a D. Okay. So I think I'm going to stop there because it's already at 8 minutes, and I'll do the other ones too.